Now we'll get started here. So Java 9 modules, what's the hype all about, right? Oh, and by the way, I'm Brent Wilkins. I'm with Hobby Lobby IT. Been doing Java development for about 16, 17 years now. And previously with Hertz and then now with Hobby Lobby. So that's me in a nutshell. So Java 9, let's talk a little bit about Java 9 before we get into modules. So, and if my screen will quit trying to get ahead of me. Java 9 was released in September of 2017, and it's already out of life. It's already end of life. So starting with Java 9, they started with the, once they went to the module system, we'll talk a little bit about that in a minute, that what it allowed them to do is to start releasing more frequently. So they're going to release every 6 months now, which means that each release is going to be end of life in 6 months. But it also means that they can release much smaller features. They don't have to do huge releases like they have in the past where they release a whole bunch of stuff together. Yeah.
I was just about to ask that.
Yeah. So currently Java 8 is their current, what they call long-term support, LTS. And it will be end of life January of next year, 2019. So for commercially. So I think for another year after that, or maybe it's vice versa. Anyway. But yes, Java 11 will be the next long-term support release, and the long-term support releases will be released or will be supported for 3 years. So Java 11 will be supported for 3 years beyond that, which will probably put you up to Java 117 by then, I think. Or so. So anyway. Just so you know that, yeah, as of the release of Java 10, Java 9's already been end of life. And it gave us several new features. And so before we get into the modules, let's just go over a few of the other features that came with Java 9. One of the big ones is the J shell, which is the REPL, which is read, evaluate, print loop, and can also be used for scripting. So from the command line, let's just slip out there real quick. So J shell brings up the shell, and from the shell you can do anything you can do in a Java program. So int stream numbers equals int stream of. There's a new one they just came up with. Remember when you used to create lists and you would then try to initialize the list as you created it by using the curly brackets and then putting everything within the list. And now they've got the of feature, so you can just tell it what you want in the list right as you declare it. And then we can, of course, then go through for each. System.out, system.out, colon, print line, and it'll output everything in the list. So lots of stuff you can do with the J shell. You can also use it as a scripting language now, and just like Bash scripting language or other languages that you can run from the command line. So anyway, that's for another talk. The collection factory added new methods. I showed you the of method. It was on an int stream. The of is also on lists, sets, maps, streams. All have the new of method. There were stream API improvements. Oh, there it is. Drop while and take while, some new commands that you can do. We won't get into that. Like I said, that could be for another talk. They also added private interface methods. With Java 8, they introduced default methods in interfaces. And in Java 9, you can now have private interface methods. So those default methods, which are callable, can call other private methods within the interface, so you don't have to have the concrete class. So again, another talk to explain that in further detail. And then the holy grail of features. I guess it's called the holy grail of features. It's the whole reason why the big hype behind Java 9 is the project module platform system. Maybe it's a holy grail, maybe it's not. I don't know. I'm not sure. There are definitely going to be companies that are going to use it. There's going to be other companies that it's not that big a deal to. Yes, could. It could. We'll look at that a little bit in the demos, and my microphone is. There. Okay. Sorry, microphone malfunction, or microphone stand down. All right, so the Java Platform Module System, AKA the Project Jigsaw, was first initiated in August of 2008 and was slated for release with Java 7 until they started actually trying to implement it. Their first try at it and everything didn't work good. They were trying to do an external type thing, and it didn't work out so well for them. So it did not go with Java 7, nor with Java 8. As Java 8 was approaching, there was a lot of talk about the Project Jigsaw. There was some pushback for some other big companies on it and stuff, and they wanted to test it out more and make sure that it was tested real well and that it was backwards compatible and everything, so they pushed it to eventually to Java 9. So it has been in the works for nearly 10 years. So what are the goals of the Java Platform Module System? So one of the big goals they wanted to do is they wanted to scale Java's SE for smaller devices. So right now, whenever you deploy the rt.jar. And for Java 8, that's approximately 61 megabytes. And it's full of a lot of stuff that you're probably never going to use, such as java.corba. And they're deprecating it, even though it's still there, they're deprecating it, and they're hoping to remove it in the next release or two. But there's other things, like if you didn't write a Swing app, then you don't need all the Swing stuff, or the AWT stuff. You don't need JavaFX if you're not writing a JavaFX app. But you have to deploy it with that rt.jar, so all those classes have to be there for you. So one of their main goals was to break that down. So they broke rt.jar down into submodules, or modules, 95 plus modules. So much smaller. The base module, java.base, is about 15 megabytes. And that's required by all modules, and we'll see that in a minute, that's a mandated dependency of all modules is java.base. So at a minimum, you have to have about 15 meg. And here's a list of some of the, this is just some of them. Like I said, there's 95 plus. I didn't want to fill up several slides with displaying all of them, but you can see how they've broken things down into modules and even submodules below that. I mean, if you think of like Java Management and Java Management.rmi, kind of another submodule underneath that, you can release them separately. You don't have to release them, or you don't have to put them together if you don't need to. So here's the graph. I was wondering how this was going to look on the big screen. So if you look down here at the bottom, I don't know if you can see it down here at the bottom, but there's java.base. Everything extends from java.base. And so there's Java XML right here, extends Java base. Java SQL, which extends XML, and logging all extend base. So this is just kind of the graph of how they broke everything out. The second goal was to improve security and maintainability. So one of the big things with jar files now is when you put a jar on the class path, you basically make everything in that jar, all the public and protected classes, are accessible by anybody who has that in their class path. So that just opens everything up. So what if there are classes that are written, that are public, that really shouldn't be used outside of that jar file? And there were some that were actually within Java that were never meant to be used. In fact, in the documentation, they said, don't use these, but people use them. So this is going to allow them to help people break those dependency on those classes that really shouldn't be available. So they're gonna, and we'll see in a minute how they do that. So I'm not gonna get into talking about a whole lot right now. They also wanted better application performance. So if you don't need all those modules, you only include what you need, you're gonna have a lot better performance because it's not gonna have to class load a bunch of stuff that you're not gonna need. And then easier to construct and maintain libraries and applications. So it'll give you greater control over how your application can be accessed. So what is a module? I'll take a drink before we talk about this. A module is a container. So if we think of a class as a container of fields and methods, and a package as a container of classes and interfaces, a module is a container of packages. So all those packages that are in your jar are going to be contained within the module. And the key to all this is the moduleinfo.java file. So you notice that it has a .java extension. It is a Java file, and it is a first-class citizen in the Java world. In other words, it's a compiled class file. It compiles down to a class file, and its existence in a jar makes it a module. So you can still compile jars without the module.info. Even in Java 9, they would just be standard jar files. Everything is accessible at that point. But if you add the module.info, it's now a module, and you control what can be accessed in there. So what is the purpose of the moduleinfo.java file? This is where you define the dependencies that your module requires, and you define the packages from this module that will be exposed. So this is where you can allow people to access certain classes, but you can hide other public classes that you don't want them to actually access. Java.base is required by default. Actually, you don't even have to list it. It's mandated, so every module.info file, by default, will have it there. You can expressly require it, but you don't have to. Modules must begin, the module class itself must begin with module, and the module name must be unique. So another thing they wanted to work on is class path issues. So the problem, or not so much class path issues, but package and class collisions. So you could have multiple jar files on your class path, and in those multiple jar files, you could have the same package name, and in some cases, the same file name. And so if the package and the file name match, the class loader doesn't know which one to load first. So what does he do? He just loads the first one that he comes to. Once he's loaded, it's loaded, and that second one never gets loaded. And we've all run into this problem, I'm sure, where you're running your software and everything's running great until you put it out to production, and something in production loads first, and suddenly your stuff quits working. I know when I worked for Hertz, we had this problem because WebSphere deployed their own JDK, and it would load that JDK, it would load WebSphere stuff that he needed first, and then when your app went to run something, if you need something with a different version of say, XML or Xstream or something like that, and he had loaded something first, it might have been an older version, and you're trying to use a newer version, his would always win, and your stuff would end up breaking. Yeah, method not found exception. Gotta hate those at runtime. All right, so one of the things that you put in the module file is requires. So if your module requires another module, then you list it here in the requires. It must be another module. You don't add requires to packages. You require other modules. If you're requiring a jar that's not modularized already, and there will be a bunch out there, because not all companies are going to jump on the bandwagon and modularize their jar files, You can still access them in your module. You would use the name of the jar file, but without the version. Versioning is still going to be handled by your build system. So Gradle, Maven, Ant, whatever you're using to build your stuff is where you're going to handle all your versioning. Now there is, with Java 9, they do allow for multi-module jars. And I just peeked at this just a little bit. I didn't really want to get into it too much here. But you can actually declare in your manifest file a different path in your code that would work for different versions. But you can only go one version prior to Java 9. JDK version. Yeah. So you could say, yeah. Exactly. Thank you. So what he said, if you're running Java 9, you would use this path of code that's been compiled with Java 9. If you're running with Java 8, you would need this compatibility version that where the new stuff that's been added to Java 9 is not there. Okay. Requires has a couple of options to it. You can require transitive. This allows the module to basically state that I require this version, therefore any module that requires this module is going to require that as well. But if you mark it as transitive, then the other module does not have to expressly add that to their module.info, unless of course they're dependent upon the same module for code within their module, if that kind of makes sense. So they're not going to make you, if you include java.base, well, let's say you include java.xml, and java.xml has a requirement on something else, then if it's marked as transitive, then you won't have to include that in your module, require that also in your module, unless of course you need that expressly as well. Don't know quite how to explain that. I think I just made it worse trying to explain it more. So, all right, the second one is requires static. Static is for those classes that you need at compile time that aren't necessarily going to need to be there at runtime. So if you think about it, you have to have a requirement for JUnit or Mockito if you're going to run JUnit tests in your class, right? Because you're basically stating that these are the modules that I need to compile my code. But those aren't going to be needed at runtime. Because after they've run the JUnit, when they're running JUnit tests, they're needed. But when you're running in their production environment, you're not going to be running JUnits or out there or Mockito or whatever. So you can list them as static. Exports. So the second command that you can do within a module info is exports. This is where you define what packages are you opening up for people to use within your module. So only packages can be exported. All the public and protected classes in that package then will be exposed to be used by whoever's depending upon this module. Sub-packages, however, so in other words, if you had com.jug.demo and there's another package underneath that, com.jug.demo.impl, you would have to declare it in its own separate exports line. So it doesn't, just because you export a package, all its packages underneath it are not expressly exported. So it's only that one package. So if you think of it in the terms of maybe interface implementation, where you have the package with all your interfaces and you have the .impl for all your implementations, you could expose the interfaces but not expose all the implementations. Now there's some, I know if you do that, then there's how are people going to use your interface, basically. And there's some other stuff that we're not going to get into because it's a little bit more involved, but there is a use and provides where you can basically then expressly tell them what package has the implementations that they're allowed to use with those interfaces. And but we won't get into that. It's a little too much for today. So maybe on a more in-depth talk. Package names being exported must have a unique name across all modules. So in other words, two modules cannot export the same package name. So once again, they're trying to protect against package and class no such method found or no such class found or whatever. They're trying to protect against that by making you uniquely name things. Now, there are going to be clashes out there. I mean, how can one person developing on one side of the world not know that somebody else on the other side of the world may have used the exact same package name, exact same class name? It just means that you cannot put both of those jar files on your module path for your application because of the clashes. Opens allows your classes, your public, your private, or your protected and your private classes to be discovered via reflections. So one of the things with a jar file is you could put private classes in there, but they could still be discovered via reflection, and you could still actually call their methods using reflection. So they wanted to close this door. So with that, everything in your module is basically closed until you open it. And this one opens your class to allow it to be accessed via reflection. So there's a couple ways you can use open. You can use open before the module declaration, and it will actually open the entire module to reflection. So instead of having to basically add an opens clause for every package that you want to open, this just opens the whole module up. Or you can say opens in the package name, it'll only open that one package name. You have to list this besides exposing it, or exporting it, excuse me. So you'd have to export the package name and opens the package name. You have to do them on two separate lines to maintain. It's not like just because you've opened it, it's automatically exported. So some of the command line features or parameters have changed. So there's some new parameters that have been added to the Java-C, the Java command, the compile command. One is module path, where you can list the path where the modules are at. Now this is not the JDK9's modules. Those are on the path automatically. But this is a module path of any modules that are external that you may want to have your application use or compile against. The module source path is just a list of what's the source directory where all the source files are that the module is going to need to include in its module. So the Java has added Java command has also added a few new features. There's module path once again. So module path has actually been added to a lot of the different command line options so that you can point to the directory that has the modules that need to be included. So for Java, this would include, this is a lot like the class path. This is telling it where is the path for of all the modules. Module is much like the -jar command, where when you did java-jar, it would actually run an executable jar. So the -- module allows you to run an executable module. Describe module is just a, it doesn't actually run anything, but it will allow you to define, or it just describes what all is exported, what's required, what's open, what's provided, used, and so on and so forth within that module. So you can, it kind of is a list of everything that is required for that module. And then list modules will give you a list of all the observable modules on the module path and within JDK9 itself. And those last two are basically, they run and they exit immediately. So it doesn't actually compile any code. And then a new command was added called JLink. And JLink is where they really got their scalability is for all their scalability that they were trying to add into the system. And it allows you to create your own JRE, basically. So you can limit everything in the JRE down to just what you need to run your application. So this is really good for a lot of the smaller mobile platforms. Instead of having to deploy the 65 meg rt.jar with it in order for that to run, you can now deploy it with your own jar file, and it'll only have the stuff that you need on that system.
Good for desktop app, microservices, all those things.
Yeah.
Bundle it.
Yep, bundle it up. It also has a module path, and then so you give it the module path to where the modules are at, but then you have to tell it what of those modules are you wanting to add to your JRE. The first one, you can just give it the path. You don't have to actually explicitly give it one particular jar file. You can just give it the whole folder. But that folder may have hundreds of jars in it, and then the add module just says, I only want to add these modules to my JRE. And then the output allows you to declare the folder where it's going to create that. And when it gets done, it's going to create a folder. It's going to have a lib folder with all the jars in it that you need, and it's going to have a, I don't remember what else it puts in there. It's, yeah. Yeah, thank you. It's got a bin directory and all the other directories you need in order to zip it up and send it. I forget they can't hear you, so these guys can hear you, but Slack channel can't. So I better repeat what you're saying. Okay, so we're time for a demo.
Hey, before you go, one of the benefits also with the module system is if you're running a fully modularized JRE, the JVM will refuse to start up if you declare any dependencies on modules, those are missing. So, we've seen a lot, especially, even with web apps, if the application starts, it deploys, whatever, and you do something, and then at runtime you get a class definition on count exception. Because it has no way of knowing that the jar file class is missing. But with the module system, you declare your dependencies, and when that comes up, it's going to that module graph into those modules missing, it will refuse to start. So you'll know early on if your runtime environment is actually the same.
Okay, I'm just going to repeat that for the Slack channel people. I'm sure you probably couldn't hear him, but one of the benefits of the module system and creating your own JRE, or even just creating a system that's using modular jars, is that at runtime, when the server is coming up, the JVM can actually read that module graph, and if he recognizes that something that is required in those modules is not on the module path, it will refuse to even start. So you don't run into these problems where you forget to put something on the class path, everything runs fine, and then finally you get to a class that needs that a package or a class within a package within one of those jars, and it's not on the class path, and boom, it crashes at that point. And you're already up and running and maybe out in production. It might be one of those edge cases that only gets hit once in a blue moon. So this will actually won't even refuse. It will refuse to come up until you have everything in place. So that's a good point. Thank you for bringing that up. Okay. So we're just going to start, and we're going to create a little project here. So I've got a OKC JUG folder here. There's nothing in it. So we're going to create a little hello world application. And I'm just going to go ahead and create the whole folder structure in one command here. All right, so we're going to create a module called Hello World. It's going to be our executable module. Within that, it's going to have a package of ComJug demo main, and main is where we're going to put our main application. So let's go ahead and build that main application. I'm going to call it hello world.java. All right, whoops. Package com.jug.demo.main. Better put the semicolon. Oops. Classes are not private. Or this class is not private. Public class hello world public static void main. And the old, the old,
Credit risk is going the same line.
yeah. We're not going to get into that discussion today, folks. There's also no spaces after the parens. Yeah. I'm old school. All right. So, whoops. This is your typical hello world with the main class, or the main method, just simply printing out hello world. All right. So to make this a module, we have to have a module info, right? So in hello world, we're going to create a module info.java. So what's the goal of this? All we want to do right now is we want to execute hello world, right? So our module is going to be called hello world. That's now the name of our module. It doesn't have to match the folder structure underneath, but it's better if you do. And we're going to export com.jug.demo.main. Remember, we export packages. We require modules. He has no requirements right now. So I take that back. He does have one requirement, it's java.base, but java.base is there by default because it's mandated, so we don't have to declare it. We could, it won't complain, but we don't need it. Or we don't need it. We don't need to. What in the world? What is going on? This thing is freaking out on me. What is going on here? All right. Nope, it's not the caps lock. That is not the space bar, or tab key, I'm sorry. Escape. Okay. So now we're going to compile it. So Javik, and let's see, we need to make a couple directories. Let's make a target directory for all the classes to go in, and we'll make a mods directory where we're going to put our Java modules. All right, so Javik-D target, that's where we're going to put the class files. Let's see, module source path is the source directory, and then we need to tell it what to compile. So find source hello world. Nope. Java dash name, sorry. That was going to complain at me. All right, so there was only two classes, but instead of having to type both in, I'll just use the find command. And so we compile it. So now we've compiled the class files. So if we look at the target directory, target/hello world, you see there's a module info.class file, and then in the com main, there's the hello world class file. So it's compiled it now. All right, so let's create a module out of it. So we will create a module called hello world.jar. And we're going to declare a main class. This is going to add the main class to the manifest.mf so that I don't have to declare it any further. When I go to run it, I don't have to tell it what class has the main method in it. I'll just go ahead and do that here. It's hello world. And then tell it where the class files are at. They are in target, hello world, dot. So now we have a jar file. So remember I told you in the Java there is the, well, first of all, so we created the jar file there in the mods directory. So if I tell the Java command, /p is the same as, is the shortcut for -- module path. So I just use it because it's faster. We're going to tell that that's mods. Oops. So it knows where to find the modules. And then we're going to tell it to describe a module from within that path. Remember, since that's a path, you have to tell it which one that you want to see. And we want to see hello world. It's the only one in, actually, it's only one in there. So we just, here we don't have to path to it. We just need to tell it which one of those modules you want to look at. And it tells you that hello world exports ComJug demo main, and there's the requirement on java.base, which is mandated, so it's automatically there. So let's run it. Once again, we give it the class path where the module is at. And then we use the module command to tell it which module in there are we running. Boom, hello world. Yay! That's wonderful. So we have a module that prints hello world. So good for a demo, not really good in real life, right? So all we've done here is use the exports. So now let's do one where we have a module that's, or where hello world is now dependent upon another module. And let's take a look at that. So we're going to create another directory. We'll call this hello helper. Keep forgetting to put my -p on there. com/jug demo helper. All right, so this one's going to have it's going to be com.jug.demo.helper. I did not want to use com.jug.demo.main again because remember how we talked about packages have to be unique. So let's create the helper class. Hello helper.java. All right, package com.jug.demo.helper. All right, so we're just going to create a static method. It's going to return a string. Let's call it get name, be the name of the person we're going to say hello to. We'll return world from a module. Let's say from a required module. All right, so all he's going to do is just a static class can return this string. So first thing we have to do is we have to compile it. We can compile it right into the same target folder, but it's going, since we're going to tell it to use the source files under hello helper, it'll create another folder called hello helper in there with all the class files under that, so we can keep those separate. Module source path, once again, it's telling you where the source is at for the module. And then find hello helper, name. com.jug.demo. Okay. So what happened here? I tried to compile this as a module, but I didn't create the module info.java, did I? So that's what he's saying. He's saying you're trying to use a package that you haven't exported. So you can't use the module source path to tell it the source is there for a module because you don't have the module.info there. So it catches it at compile time to let you know that something is missing. So what happened? There we go. All right. Source.hello helper module info .java. That was not it. Did it not create anything? Okay. .java, not JAA. That wasn't going to work. So, all right, module hello helper exports com.jug.demo.helper. Oops. All right, so let's go back up here and do the Java command, and now it compiles. So now since you have a module.info and it says you can create a module, or you can compile this as a module. So now using the jar command, we will create a jar file out of this. This one, we don't have a main class on this one, so I'm not going to declare the main class. So for this one, we just need to tell it where the class files are at. And we'll create the jar. So once again, if we look at this with the, so it created the jar file, hello helper. It's in the same mods directory as the hello world. And then if we use the describe module, how am I looking at time here? I have plenty of time, don't I? Hello helper. All right, exports com.jug demo helper and requires Java base, which is mandated. So now we have the helper class ready. So now we can go back and we can add that helper class to our hello world. So we'll import com.jug.demo.helper. Hello helper, and then we'll change this to hello plus hello helper dot get name. All right, so to compile this, we need to be sure and list the module where the hello helper is at. And then we need to declare, dash D target module source path source, and then, find source hello world name. It didn't work, but I added it to the module path, It should find it, right? What did I forget to do? I now have, no, I have a module, but I added what? I added a dependency to the class, didn't I? So we're missing the requires. So it's not going to allow you to compile this because it's missing, which is not really a big deal. I mean, you couldn't compile, well, I guess you could compile something as long as it was on the class path, right? So if you'd added the class path in Java compiler, it would have allowed it. But in this case, it explicitly knows that you require that. Because you could add things to the class path that it doesn't depend on, right?
You could even add that to the module path. It's not required, it's not a mistake.
Right.
It's not a physical class.
Right. And so it is a module, so it needs to go on the module path. If I were to turn around and put this on the class path, I haven't actually tried it, but I think it should work. It should actually find it, but it basically exposed everything that was in that module because you've got it on the class path, not on the module path. The module path is actually going to look at the module, that module.info, and expect things to be there. If you put it on the class path, it'll still work, but you may get unforeseen results, or not unforeseen, but unexpected and maybe unwanted results. All right, so we go back in here and we require hello helper. So remember, we require the modules, we export packages. So all I have to give it is the package name, or the module name. I don't have to try to, tell it what package within that module that I'm requiring. All right, so now if I compile, it's requires, sorry. It's even smart enough to know when you're making stupid mistakes. And that's not the way you spell requires. It would have caught that one too. All right, so now it compiles. So now let's create the jar file. Mods. Hello world.jar. I want to declare the main class again because this is the one that has the main in it. And then tell it where the class path is at, or the classes are at, sorry. All right, we created the jar. So now let's look at the dependencies of this jar. So we'll do the mods, describe module, hello world. So now you see that it exports com.jug.demo.main, but it requires hello helper explicitly, because we had to explicitly require that one, and then java.base via mandated. So now let's run it. Could not find or load main class com.jug.demo hello helper in module hello world. What's that? I did. I put -p mods. That's the module path. Well, this didn't happen when I was setting this thing up. Could not find or load main class. Ah, thank you. It was hello world. So that was me being stupid. So it can't solve all stupidity. How unfortunate. Hey, looky there.
There we go.
Hello world from a required module. So now we've added that requirement in there. So that concludes my demo portion. So basically we're to the point of questions. Does anybody have any questions on anything?
If you were to put the hello help jar file out of that mod directory, rerun it. Just like I said there, it should fail.
So you want to do,
Just move from mods hello helper jar. Mods, not source.
oh, you want to remove it from the jar?
Move the jar file out of the mods directory. Try rerunning hello.
Okay.
I say remove because it's not destructive. It's not privileged. Since most of us use 90E.
All right, so let's move that. Just move it back one right into this one. Okay.
Now rerun it should.
So now if it's not on the class path, error occurred during initialization of boot layer. Module hello helper not found. It's required by hello world. So I can't even run it because it's not on the class or on the module path, excuse me.
So if you add a -cp hello helper.jar, I'm going to run it up.
Module hello helper not found. Required by hello world.
It's on the class path, so it's not being alerted to the module.
Right.
The class is there, but the module's not.
So the deal with running, when you run with a module, and you add a jar file that's not been modularized, you still have, if it's required by the module, you have to put it on the module path. So you can put a regular jar file on the module path. What happens is that Java under the covers creates what's called an automatic module out of that class. So it basically reads that class looking for its dependencies and can therefore create a module on the fly.
Based on the file.
Right. What's that?
Based on the file.
Right.
Unless there's a manifest.
Right. And it basically goes through and will build for you a module info.java on the fly that basically exports every package within your jar file, and we'll add, I'm not sure if it can do the, I guess it can figure out the requirements as well. Yeah, I'm not exactly sure how all that works, but anyway, but it will export all the, it'll create all the exports for you, so.
For library developers, if you're not ready to modularize yet, is, maybe you're ready to modularize, but one of your things is not yet a module. There's an entry that the manifest file is called that basically can allocate the module name so that when it makes an automatic module, it uses the stable name so that developers can start declaring the dependency on that module until it's your library's fully modularized.
All right, for you on the Slack channel, what he said was, in regards to automatic modules, if you're creating jars and you're not ready yet to go to modules, there is a parameter that you can add to the manifest.mf file where you can actually declare the module name for your class, even though you're not ready to modularize, not your class, for your jar. Even though you're not ready to go to that yet, you may be working toward that. What that does is when it creates the automatic module, it'll use that module name, and then it just prepares anybody that's using your classes or whatever to be prepared and ready when you do finally modularize to know what the name of that's going to be. Any other questions? All right. So here's some resources. I used quite a few resources to put this together. So bits and pieces were pulled out of multiple different talks and tutorials. A good one is Mark Reinhold, who I think is is probably the architect for this whole thing. He's the one that the very first article I read by him was back in 2008, was a blog post which he was proposing the whole Java module system. And so in the state of the module system here, OpenJDK, I think it's from 2016 is when he wrote this particular article. But a lot of good information in there. There's a Java 9 modules cheat sheet. It's just a little one-page cheat sheet that gives you all those new command line parameters for Java and Java and jar and all those. And then dzone Java 9 modules part 1 is kind of where I built this whole demo from. So it's from that particular site. So that's all I have. Thank you very much. Appreciate you guys coming out on this rainy day.